So this video will look through the Unit 6 material. So we did factoring and we dealt with radicals. So actually starts with the radicals. Remember, a lot of times you're just looking for things like perfect squares when there's a square root. So we know that the square root of 64 is 8, and then the square root of x squared is x. So we can just do 8x. Here, 120, we probably need to break that down. That's 12 and 10, 6 and 2, 2 and 5, and then 3 and 2. So we've got a group of 2's here that we can pull out. And then left behind, well, we can also pull out a pair of x's, and none of the y's can come out. But a 3, a 2, and a 5 are left. 3 times 2 is 6 times 5 is 30, and there's an x and a y still left underneath. Here we're looking for groups of 3. So we'll break 24 down. That's 12 times 2. We have 6 times 2, 3 times 2. So there is a group of 3, 3 2's. So we can pull out a 2. There's a group of 3 A's and there's a group of 3 B's. But what gets left behind, there's a 3 that's left quote unquote in jail along with one of the B's. Here we're going to do some foiling. So if you'll allow me to erase my work from before, go ahead and FOIL these together. So we end up with 2 times the square root of 64. I don't know why I wrote 6. Minus 8 square root of 8 minus 6 square root of 8 plus 24. So remember, the square root of 64 is 8, so we have 2 times 8. We can combine, this is almost like terms, remember, since that's the square root of 8 and the square root of 8. So negative 8 minus 6 is minus 14 root 8 plus 24. Don't have a whole lot of room here, so we end up with 16 minus 14 root 8 plus 24. And I can go ahead and I can combine the 16 plus 24, and that's 40, minus 14 root 8. And we can break 8 down. That's 2 times 4, so 2 and 2, which means I can pull a 2 out. So my final answer here, 40, when I pull that 2 out, I'm left with 28, right? Because you go 2 times the 14 that was already here, and there's a 2 left underneath. So there's your final answer for number 4. Number 5, we're just looking for like radicals since we're adding everything. And we have one with the square root of 3. So 2 minus 5 is negative 3 root 3. And then we saw that root 6. None of those are going to break down, so that's as far as we can go. Here, remember, with the exponent kind of outside, we quote-unquote distribute it, so we end up with x squared, 8 to the third, x to the third. So end up with 5 x's, and I'm just going to leave that as 8 to the third, because it's going to be a pretty big number for us, so let's just leave it as is right there. Here we got a square root of 7, square root of 7, so we can do 6 root 7 minus 5 root 2. That's as far as we can go there. Here we're going to distribute the 10 in. End up with 10 root 2 minus 60. And since the 60 doesn't have a radical, we're going to leave it alone. When you multiply these, remember you multiply the numbers out front. So we got 5 times 2, which is 10. And then multiply the 6 and the 8 under the radical is 48. Now, end up with 4 times 12, and 4 times 3. I could break that down further, but I have a set of 4's that I can go ahead and pull out. So when I pull those out, this turns into 40, and then 3 is left behind. Here again, now multiply the numbers together. Excuse me, let me get rid of that. So we'll end up with 2 times 8, which is 16. We'll have 5 x's and 4 y's. Now, just start kind of factoring stuff out. So 16 is 4 times 4. Again, I could break it down further, but I have a set that I can go ahead and pull out. There's a 4. There are 2 sets of x's that can make a break for it. There are 2 sets of y's that can make a break for it. And then there'll be 1 x that'll be left underneath. All right, and we'll try one more of these problems with foiling. So we have square root of 60 when we multiply those. Minus 1 square root of 20 plus 5 root 3 minus 5. And then let's see if we can break anything down. So this will be 6 times 10, 3 times 2, and 2 times 5. So I could end up pulling 2 root 15 there. 20. 4 times 5, so there's 2 times 2, so do minus 2 root 5, and then plus 5 root 3 minus 5, and none of those will simplify any further, and we can't combine anything else, so that's it for number 11. Sorry that it kind of ran into 12. So we'll rewrite this square root of negative 36i. Now this is where we got to remember, square root of 36 is 6, but since there's a negative underneath, you have to put that I in there. When you combine these imaginary numbers, remember it's a lot like combining like terms. First thing we need to remember here, we need to distribute that negative. So 2i turns into minus 2i, and then 7 turns into minus 7. Combined like terms, we end up with 1i minus 4. Here's an example where I think some of these are going to start to break down. Again, initially, we don't have any like radicals, so we can't add them together. But if we take a second, so this is 4 times 3, which is 2 times 2. So that'll turn into, pull a 2 out. There's already a 2 there, so 4 root 3. This is 9 times 3, which turns into 3 times 3. So I can pull a 3 out, left with a 3, and then minus 3 root 3. All of a sudden, sure enough, all three of those have the same radical. So 4 plus 3 is 7, minus 3 is 4 root 3. With our factoring, so here, we saw this a couple days ago. We want the factors of 15 that add up to be 8. So I believe that's 5 and 3. So x plus 5, x plus 3. Here we want the factors of negative 30 that add up to positive 7. So I think 10 and 3 will do it. We just got to get the right combination. I think it's positive 10, negative 3. So x plus 10 and then x minus 3. And then we look at number 17. It's a little bit different because we have that leading coefficient. So remember right here, because of that 6 that's sitting here, we need to use, because of the 6x, we need to use our bottoms up method, if you will. So multiply a times c. So for us, that's 6 times negative 7 is negative 42. So we need factors of negative 42 that add up to be negative 41. I believe that's going to be negative 42 and positive 1. So initially, we're going to put x minus 42, x plus 1. This is where the bottoms up comes in. Again, because that 6 is the leading coefficient, you divide both numbers by 6. Simplify if you can. So 42 divided by 6 is 7. We cannot simplify the 1/6, so this is your bottom. The bottom of 6 comes up, so that turns into 6x plus 1, and that is fully factored. All right, the last thing we look at this particular review sheet was solving equations with square roots. So remember, you want to isolate the radical. Even if there's stuff underneath it, just isolate the radical, we square both sides, and we solve for x. So for example, number 18, the radical still has this minus 3, so let's move this 3 over. We got 2x plus 7 equals 3. Now we're on to step 2, so square both sides. So that turns into 2x plus 7, the square root of that squared equals 3 squared. Well, when you square a square root, we're left with 2x plus 7 on this side, and we're left with 9 over here. And now we just solve it like we would a normal problem. So 2x equals 2. Divide both sides by 2. And so for this one, x equals 1. Here we got to isolate the isolate the radical. So add 3 to both sides. We end up with square root of 17 minus x equals 5. And when we square both sides, we end up with, give myself some space here, 17 minus x equals 25. So we'll subtract 17 from both sides. So we end up with negative x equals 8, which means positive x equals negative 8. And then the last thing, there's a radical on both sides, which means we can go ahead and square both sides right away. So 6x plus 1 squared, 2x plus 9. We're going to undo the square root by squaring both sides, which means really we just have 6x plus 1 equals 2x plus 9. And now just start moving pieces to combine like terms. So subtract 2x from both sides. So 4x plus 1 equals 9. We'll subtract that 1. So 4x equals 8. Divide both sides by 4. And we end up with x equals